to you really briefly about how to find the amount of charge a charged object has. So let's just imagine we have 6 different balloons. There's my best picture of a balloon. And I'm going to draw a situation for you, and we'll just kind of work through how to find the amount of charge, which is typically measured in coulombs, or capital C for the unit. So let's imagine that we start with a balloon that has an even number of electrons and protons. Kind of an unlikely situation, but let's just say it's got the exact same number of electrons and protons. Tons and tons and tons of them, but I'm going to model that by just drawing a few. Here's an electron, another, and another, and then here's a proton, another, and another. So we can say it's got the same number of positives and negatives. And they each have the same quantity of charge associated with them. An electron has a charge of negative 1.6 times 10 to the negative 19th coulombs, and a proton has the same amount of charge, but positive. So they kind of balance each other out. There's no more positives than negatives, and there's no more negatives than positives. There's no excess electrons, there's no excess protons. So we call that a neutral object. In fact, very often we don't even draw an even number of charges. We just leave it alone to show that there's no extra negatives, no extra positives, and that's our base case scenario, saying, well, we don't have any charge. That's 0 coulombs for the amount of charge. And then again, it's a very unlikely situation, but let's imagine you charge the balloon, maybe you rub it on your hair or something, and it used to start with even numbers of protons and electrons, but for some reason now it has one more electron than proton, one excess electron, if you will. So instead of drawing a bunch of negatives and a bunch of positives and one more negative than positive, I'm just going to draw the one excess negative. Here's the one extra electron that this balloon has. Really unlikely situation, but we're just kind of imagining it's got an even number of positives and negatives until you put one extra electron on it, and that's what I'm drawing there. And each electron has a charge that's negative and a magnitude of charge of 1.6 times 10 to the negative 19th coulombs. Okay, now let's imagine you rub the balloon a little more and you put even one more electron on this balloon. So instead of having one extra electron, one more electron than proton, now it's got 2 excess negatives, excess electrons, 2 more electrons than protons. And so as a result, it'll have twice the charge that it used to. It used to have this amount of charge. Since each electron has a charge of negative 1.6 times 10 to the negative 19th coulombs, and there's 2 extra electrons, it'll have twice that amount of charge, or negative 3.2 times 10 to the 19th coulombs. And I know you're getting the hang of it. Let's just do one more. Let's say I've got a whole bunch of protons, a whole bunch of electrons, and 3 extra electrons, 3 more electrons than protons. So now the charge that I have for this is 3 times the charge of each electron. And that'll be negative 4.8 times 10 to the 19th coulombs. And I think you're seeing a pattern here. To the point where I could say, all right, let's imagine now that I have this balloon that has a lot of excess electrons, a lot more electrons than protons. In fact, let's say we don't even know how many, it's just n more electrons than protons. More electrons than protons. It's got n number of extra electrons. And since each electron has this much charge, then if you have n extra, you'll have n times this much for the charge. And so you can kind of use this pattern to figure out the charge based on the number of extra electrons. If you had extra protons, like for example, let's say this balloon here somehow or another had started even numbers of electrons and protons, and then an electron was taken away maybe. So now it's got 1 less electron than normal, or 1 more proton than electron. Protons and electrons have the same magnitude of charge, just different signs. So if you've got an extra proton, then your charge is positive 1.6 times 10 to the 19 coulombs. And you can kind of use the same pattern of how many extras you have to figure out what the total charge is going to be based on the fact that a proton has this charge and an electron has this charge.